Hi, my name is Larine, and I'm here to present the work OTA degradation by carboxypeptidase a study of mechanism and applicability. This work was carried out in partnership with my colleagues Gabriela, Daniela, Eduarda, Eliana, and Annelise. Ochratoxin A, or OTA, is a mycotoxin that is found in several products, like beer, wine, cereals, coffee, and it has nephrotoxic, hepatotoxic, immunotoxic, and teratogenic effects. Due to its wide occurrence, its toxicity, it's important to develop not only detection methods, but also the contamination methods to reduce their levels in these foods samples, and then minimize the risk of exposure to the population. Between the decontamination methods, we can highlight the biological ones because they present a high specificity and require multiple conditions to catalyze the contamination. An example is the use of the enzyme carboxypeptidase A, which catalyzes the reaction to hydrolyze ochratoxin A into its metabolite ochratoxin alpha and the amino acid phenylalanine. So, we study the action of carboxypeptidase on the levels and toxicity of ochratoxin A, aiming to apply this technique to detoxify wet flour. For this, to achieve this goal, we divided the work in 4 steps. First, the validation of the method, both chromatography and extraction. Then we conducted in vitro degradation of ochratoxin, so we could seek for potential source of this enzyme. Then we assessed the ototoxicity and OTA alpha with human neutrophils, and then we applied this technique to degrade OTA, simulating a bakery process. So at the first step, we validate the method. We use HPLC-FL to detect OTA and OTA alpha. Here we can see the chromatography conditions and the separation of the mycotoxin and its metabolite. At table 1 and 2, we can see the chromatography conditions as well as the validation of the extraction method, where you can see the good levels of the limits both for the instrument as well as the method, detection and quantification, and we present the values of accuracy and repeatability, and they both are in accordance with the validation guidelines. After this step, we conducted the in vitro degradation. For this, we used petri dishes where we added potato dextrose agar and a concentration known of the mycotoxin. We inoculate the plates with 2 filamentous fungi, Rhizopus oryzae and Trichoderma rhizei, and we leave for 5 days to see if these microorganisms were able to decontaminate the mycotoxin. After this time, OTA and OTA alpha were extracted by the validated method, and as the result, we can say that both Rhizopus oryzae and Trichoderma rhizei showed a good OTA degradation with values of around 64% for Rhizopus oryzae and around 58% for Trichoderma rhizei. This degradation showed a high and significant correlation with OTA alpha production, so this indicates the production of the enzyme carboxypeptidase A. Based on this, we decided that before applying the technique, the enzyme to degrade OTA in wet flour, it is important to elucidate the mechanism of toxicity of this mycotoxin and to see if its metabolite is toxic or less toxic. For this, We conduct a study where we isolate neutrophils from human blood donors, and we observed the absence of OTA alpha toxicity, and we were able to elucidate the mechanism of OTA toxicity in these neutrophils, which is present in this figure. And basically, what happens is that this mycotoxin causes an increase in the intracellular calcium release from the internal stores, and this release causes a cascade of events, such as production of reactive species, ATP depletion, alterations on mitochondrial amputation, which leads to death by necrosis. And then, after we elucidate the mechanism, we decided to evaluate the ability of carboxypeptidase A from different sources to degrade OTA and biotransform this mycotoxin into its metabolite, OTA alpha, which showed no toxic effect. For this, we simulated a bakery process and used wet flour contaminated with OTA at different levels and applied the enzymes at their optimal conditions, pH and temperature. We see that after this treatment, we needed to validate another method to guarantee reliable results for this decontamination. So we repeat the phase of validation here. And after, we had as results an OTA degradation varying from 16 to almost 80%. And the most promising carboxypeptidase were obtained from Rhizopus and Trichoderma raceyi. So, in conclusion with this work, we recommend the use of proteolytic enzymes of the carboxypeptidase type to reduce the risk of exposure to the mycotoxin. The transformation of OTA to OTA alpha and its effect in reducing the mycotoxin toxicity corroborate with this statement. Here are some references that we use. And I would like to thank the organization for the opportunity, my colleagues that developed this work with me, the institutions where the work was conducted, FURG and Porto University, and also CNPq and CAPES for the financial support. I leave here my email address, likupski@wayne.br. If anyone has any questions, are welcome to send me an email. Thank you for your time.